Before sunrise in the Indian Ocean, the ocean can appear completely calm. But beneath the surface, modern naval warfare often unfolds in total silence. Some of the most powerful weapons ever built operate far below the waves. Nuclear submarines capable of detecting targets from miles away and striking without warning. In a tense geopolitical environment where naval forces from multiple nations control the same waters, even a single encounter between ships can escalate into a dramatic confrontation. Today we're going to explore how submarine warfare works, how modern torpedoes can sink large warships in seconds, and why certain regions of the Indian Ocean have become strategically important for both the United States and Iran. A silent hunter beneath the sea. Modern attack submarines are designed for one primary purpose: hunting enemy vessels. Unlike surface ships, submarines rely on stealth. They remain hidden beneath the ocean while tracking targets using extremely sensitive listening systems. One of the most advanced platforms used by the United States Navy is the Virginia-class attack submarine, a vessel designed for surveillance, intelligence gathering, and precision strikes. Operating quietly beneath the water, these submarines can track surface ships without ever being detected. When a target is identified, the submarine commander has several weapon options. One of the most powerful is the Mk-48 heavyweight torpedo, a weapon specifically designed to destroy large warships. The Mk-48 torpedo. The Mk-48 is one of the most advanced torpedoes currently deployed by the U.S. Navy. Weighing thousands of pounds, this weapon travels underwater at extremely high speeds and carries a powerful explosive warhead. Once launched, the torpedo initially remains connected to the submarine through a guidance wire. This allows the submarine's computer systems to control the weapon and guide it toward the target. During this phase, the torpedo receives updated targeting information from the submarine sensors. As the torpedo approaches its target, the guidance wire disconnects and the weapon activates its own sonar system. At this stage, the torpedo begins independently searching for the ship. If the weapon loses contact with the target, it can even circle back and attempt to reacquire the vessel. When the torpedo finally reaches its target, the explosion occurs between the hull of the ship, a location specifically chosen to maximize damage. The blast can break the structural integrity of a warship, sometimes causing catastrophic failure within seconds. How submarines find their targets. Finding another vessel in the vast ocean may seem impossible, but modern submarines use highly advanced detection systems. The most important of these systems is sonar. There are two main types. Active sonar. Active sonar works by sending powerful sound pulses through the water. When these sound waves hit an object, such as a ship's hull, they bounce back toward the submarine. By measuring how long it takes for the sound to return, onboard computers can calculate the distance to the target. Passive sonar. Passive sonar works very differently. Instead of sending out signals, the submarine simply listens. Large ships create distinctive noise patterns from engines, propellers, and onboard machinery. These sounds travel through water extremely efficiently. Sophisticated hydrophone arrays mounted along the submarine's hull allow operators to detect these sounds from significant distances. By analyzing these acoustic signatures, submarine crews can often identify the exact type of vessel they are tracking. Why the Indian Ocean matters. The Indian Ocean has become an increasingly important region for global naval operations. One key reason is Diego Garcia, a small island that serves as a major U.S. military facility. This remote base hosts long-range bombers and logistical support units that allow the United States to project power across large portions of the Middle East and Asia. Strategic aircraft operating from this island can reach distant targets while remaining protected by the surrounding ocean. Because of this role, Diego Garcia is often considered one of the most valuable U.S. military installations outside the mainland United States. Iran's naval strategy. Iran has developed a unique approach to naval warfare that focuses on asymmetric tactics. Rather than relying entirely on large warships, Iran invests heavily in smaller vessels, missile systems, and unconventional platforms. Some Iranian naval units operate fast attack craft capable of launching anti-ship missiles. Others use modified vessels capable of deploying drones, helicopters, or small strike boats. In recent years, Iran has also experimented with converting commercial cargo ships into military support platforms. These ships can carry helicopters, drones, and small boats, allowing them to operate as mobile staging bases. From a distance, they may appear to be ordinary cargo vessels, but their capabilities can be significantly different. Missile threats in the region. Another important part of Iran's military strategy involves missile systems. Several Iranian ballistic and cruise missiles are capable of reaching targets hundreds or even thousands of kilometers away. These weapons are designed to threaten strategic locations such as air bases, naval facilities, and military infrastructure. By combining missile forces with naval units and allied regional groups, Iran aims to create a complex defense network that could challenge larger military powers. Historical clashes at sea. Although naval confrontations in the region are rare, history has shown that tensions can escalate quickly. During past conflicts in the Persian Gulf, encounters between naval forces have sometimes resulted in missile exchanges and ship damage. These incidents demonstrated how quickly modern naval warfare can unfold. Missiles, aircraft, and ships can engage targets within minutes, leaving very little time for reaction. The strategic importance of maritime choke points. One of the most critical waterways in the world is the Strait of Hormuz. This narrow passage connects the Persian Gulf to the open ocean and serves as a vital route for global oil shipments. A significant portion of the world's energy supply travels through this corridor every day. Because of its importance, maintaining security in this region has long been a priority for international naval forces. Any disruption to the shipping route could have major consequences for global markets and energy supplies. Conclusion. Modern naval warfare is shaped by technology, strategy, and geography. Submarines operate silently beneath the waves, tracking targets using advanced sonar systems. Torpedoes like the Mk-48 provide devastating strike capability, capable of disabling large warships in moments. At the same time, nations develop new strategies to counter these threats, using missiles, drones, and unconventional naval platforms. As military technologies continue to evolve, the oceans remain one of the most important arenas for global security. And beneath the calm surface of the sea, the world's most powerful navies continue their silent watch.